Hi everyone, welcome to section 2 of chapter 1. Today we are talking about displaying quantitative data. So in section 1 we talked about qualitative or categorical data. So today we move on to quantitative. There's actually a lot more graphs that we can make using quantitative data, so here we go. The first one we're going to talk about is the dot plot. This is probably like the most basic one. So the easiest one to make. The example I'm going to use talks about frozen pizza and its sodium content, so real healthy here. So I've listed out the amounts of sodium in milligrams in a single serving of 16 different brands of cheese pizza, so pretty exciting. Sodium, you're not supposed to have that much of it, so this is actually pretty bad, but we're trying to make a graph so that we can see, like, in 16 typical brands of frozen pizza, like, how's the sodium looking? So here we go. When we're making dot plots, a few things that we want to pay attention to. So the first thing you need to do is define your x-axis. So anytime we make a graph, we want to make sure people know when they look at a graph, like, what is this graph talking about? So our first thing that we're going to do is draw the horizontal axis and label it with what the x variable stands for. For us, that would be sodium content in milligrams. Okay, then as we make our dot plot, on the x-axis we want to label a scale, basically. So really this just involves us making little tick marks and labeling what numbers this starts at and what number it ends at. We want to make sure we go in even increments, so we can't be like skipping around on numbers. It has to be a legit like x-axis. So if you're going to go by 2s, cool. If you want to go by 10s, it's fine. You just have to go in even increments as you make your x-axis. So for us, since all our numbers are like 500 and something, 600 and something, 700 and something, I'll probably go by 10s. So as we label this, I kind of extended my line a little bit because I feel like if we go by 10s, I'm going to need some more space. We want to figure out what the smallest number is, because we can just start there. We don't have to start at 0 every time, because that doesn't make sense. We don't have any data points all the way at 0. So start at the smallest one that you have, which for us looks like it's going to be 570, I think. So we can just make that our first one. One little trick that I want to show you guys, now that hopefully you have a graphing calculator that you can use, whether it's on your computer or you have an actual one, I'm just going to pull mine up really quick. I'm going to have the graphing calculator sort my numbers for me. That way I don't have to do this myself, because, we have a graphing calculator. Let's use its technology. So here is my graphing calculator. Let me get this to work a little bit better. Here we go. So first you want to turn it on. If you hit the stat button and then edit, so hit enter when number 1 edit is highlighted. You might have numbers in there, you might not. If you do have numbers in there like I do, what you want to do to get rid of all of them is to scroll all the way up until the L1 is highlighted, hit clear, and then enter. That'll clear everything. Do not hit the delete button. If you hit the delete button, that entire list will just go away forever. You don't want that. So make sure you aren't using delete. Okay, so I'm just going to type all the numbers in I have. So 580, enter, 740, enter, 850, enter. I'm going to pause the video here and finish doing this so that you don't have to watch me do it. Okay, so I just entered all my numbers. Hopefully you guys paused the video and did the same thing too, so that you can follow along. As you can see in my list now, I am at a blank space where it's labeled L117. So that's telling me that blank space is the 17th number, which means the number that I entered just before, the 640, should be my 16th number. And that's a really good way to check, like, did you enter all your numbers correctly, or at least the correct amount. So if we look back at our data, there should be 16 items that we should have entered, so I'm good. If you ever mess up and you're like, oh shoot, that was supposed to be like 700 instead of whatever you typed. You just have to type over it 700 and then hit enter, and then it'll fix whatever you had. Okay, so now that we have everything, I want to put this in order. So what I'm going to do is to get out of this screen, there's the quit button right here. It's in blue right above the mode button. So to get to the blue stuff, you hit the blue button first. So second, mode will take you back to your home screen. This is like where you do all your calculations and stuff like that. So I'm back home. So to order everything, I'm going to hit the stat button. That's going to be your favorite button all year because this is stats class. Stat button. Just kidding. My bad, my bad. Quit again. Second stat is what we want because we're trying to do stuff with our list. And so the list button is right above stat. So second stat. And then we come to this page where you have names, ops, and math at the top. You're going to scroll over to ops. It stands for operations. Numbers 1 and 2 is sort A and sort D. Sort A means you're sorting in ascending order, so from smallest to biggest. Sort D is descending order, so biggest to smallest. We want smallest to biggest, so I'm going to choose number 1, hit enter, or you can hit number 1. And then it'll give me this parentheses. You just have to tell your calculator which list to sort. So we entered all of our data into L1. So to type L1, you see above the number 1, it's in blue. So it'll be second, number 1. It should say L1. End your parentheses with the parentheses button that's above the 9. Hit enter. It'll tell you, I did it, it's done. So now when we go back into our list by taking pushing the stat button back into edit, now all our numbers are in order. Ah, beautiful, so much easier to deal with. So now I'm gonna start making my dot plot. So our smallest number was 570. I think my next one was 580. So in order to get all my numbers onto this dot plot, we want to make dots because that's what a dot plot is. Who would have thunk? So above 570, I'm going to have a dot. Above 580, I'm going to have a dot. Then 610, 630, and so on. So one thing you want to keep in mind is that when you place your dots on your x-axis, we can't skip numbers. So I said we were going by tens. Even though my next number after 580 wasn't until 610, I have to list all the ones in between. Since I was going by tens, 590 and 600 still have to be there on the x-axis, even though there's no dots above them. My next one after that was 630. So again, 620 I still have to list, but there's just not going to be dots above it. And then we go to 640 and then 670 a bunch of times. Which means that 650 and 660 have to be listed, but there's nothing there. And then we had a couple entries at 670. And then to scroll down on my list, I'm just going to use the down arrow. So it looks like there's 2 670s and then it skips to 690. So I'm just going to continue. $690, $700, $740, $780. This is why I needed to extend my line, because I'm still running out of space. So let me try to extend it again. But man, some of these pizzas, so much sodium, really not good for you, in case you were ever wondering. Okay, so 740, 780, 790, 850. Ooh, a bunch of 850s. Okay, so I'm just going to finish this off. You can pause, or I'm going to pause. Okay, I finally finished my graph. So here is our beautiful dot plot. As you can see, it's pretty spread out. And so those are the rules of dot plots. You have to make sure that your scale goes by even increments and you can't skip numbers, and then just put your dots above it. Make sure you label your x-axis, because I got rid of my label, so I'm just going to put it at the bottom here. So this was sodium content in milligrams of frozen pizzas. Cool. The label doesn't have to be super specific. As long as it's there, you have something related to the problem, we should be good. Same thing on the AP test. They're not looking for like super duper specific. As long as you've labeled it with something that's correct, you should be fine. Okay, so that's our first graph. Another graph that we want to be able to make is the stem plot. You might have learned this as a stem and leaf plot. Again, pretty basic, but also kind of nice. So stem plot and a dot plot, they're going to be pretty similar to each other because they're going to list out all the different actual like data points. So you can actually tell within each of the graphs what number each dot or each stem stood for. Okay, so in our stem plots, I listed a few rules for it. So stem and leaf is basically we're breaking up the part of the our data set into as few numbers as possible, basically. So if you look at our data set, I'm going to use the same one from before, the sodium content. You see that all of our data points end in 0. Our leaves are always going to be the last number in, or like the last digit in our data set. That's not all the same. So our last digit in our entire data set for all of the numbers would be 0. So we're not actually going to count that at all. We're going to use the second to last digit then. So the middle number would be our leaves, which means the rest of the numbers, each data point would be the stem. So like for our first data point at 570, we're going to use a stem of 5 and then a leaf of 7. And then when I make the key, because one of the rules is that you have to include a key, this is where I'm going to define like how to read our stem plot. If I have 5, line, and then 7, this actually is 570 milligrams of sodium. So this also kind of counts as like our labeling of the x-axis, because we're going to define what our variable stands for in the key, as well as like any additional numbers that have to be added in order for the reader to be able to understand our stem plot. So we're going to continue this. One of the rules was that you can't skip stems. So as I make my stem plot, if I have a stem of 5, all the leaves after it are going to start with the 5 in the data point and then end with whatever number. So my next data point was 580, so it'll have a stem of 5 and a leaf of 8. And then our next number after that was 610. So that has a stem of 6 and a leaf of 1. And then our next number after that was 630, so a stem of 6 and a leaf of 3. Then the next number was 640. 670 occurred twice, so now I have to include 2 7s. And then 690. 700 was my next number, so that has a stem of 7 and a leaf of 0. 740 was next, 780, 790, and then I think we had 850. So that's a stem of 8. 850 occurred twice, so I have to make sure I list out 2 5s, and then 870 was our last one. I don't think I skipped anything. Okay, so when I say you can't skip stems, what I mean by that is like, let's say I didn't have any 700s in my data set. I still have to list a stem of 7. So if I had no numbers in the 700s, I would still have to list a stem of 7 and then just have no leaves within it. And then I would move on to my stem of 8. And I would keep going like that. Your leaves have to be in order, which is why we wanted to put all our numbers in order in the calculator first. That helps us go through our list in order, so that makes things easier. I've included the key. That was the third rule. And then this last rule, stem can be split. So what I mean by that is you can actually split your stem so that it kind of, and this works better for larger data sets, where you can basically repeat stems. So I'm going to make another stem plot here that actually has split stems. So let me set up. So I'm going to repeat each of my stems twice, because what a split stem allows me to do is basically break up each of my leaves into like the first half of the 500s and the second half of the 500s, or the first half of the 600s, the second half of the 600s. And again, this works for larger data sets, because then you can actually see, like, do you have more towards the lower end of the 600s or more towards the higher end of the 600s? That's what splitting it does. And so when we split it, the first 5 will always refer to numbers from 500 all the way to 540. The second 5 will stand for numbers from 550 all the way to 590. So think of it as like 0 to 4, 5 to 9. And that's the case for every single split stem. So 600 to 640, and then the second 6 will be 650 to 690, and so on. So if we were to make a split stem plot, then my first couple data points are 570 and 580, so that would go into the second 5 because that's on the tail end of the 500s. And then moving on to my 600s, I have 610, 630, 640. All of those fall into the first 6. And then the 670, that occurs twice, and the 690 would be in the second stem for the 6s. So it gets split up like that. Let me just quickly continue for the rest of the data set. Okay, and as you can see, we actually have 2 stems where there's nothing in them. So the first half of the 500s and the first half of the 800s, we don't have any data points that fall into that category, so we just leave it blank. But you're not allowed to just go straight from the 700s into the second half of the 800s. You'd have to leave that stem there, even though it's blank. Okay, so, and then same thing, include a key. So the key, you can actually pick any number to use for your key. I usually just do the first one just because it's convenient for me, but you can technically pick any number that was in the data set, write that out, and then state what it stands for. So same key as before. Okay, so that's the stem plot.